Hi, in this video, I want to show how power supplies handles low voltage right through. It's with an electro automatic system, some kind of a vendor's application. So let's talk about it. So we have here a source 3150 AFX AC power supply that is programmable. So this allows us to program a disturbance in the AC line. The output of that is going into our PSB 1080-1000 for you 30 kilowatt bidirectional power supply. The AC power supply from pack power is going to the supply power to our DC power. You can see on the scope right now you have got the yellow sine wave is the AC voltage coming into the PSB. And then I've got an output programmed on the PSB just to show that it's providing an output, and we can kind of monitor something um, while the AC input line is disturbed. So let's see, it has already been doing so testing. It looks like the unit can ride through about almost 80 milliseconds of line disturbance, where the input sags on all three phases down to about 40% or like 15 of nominal voltage or so. So we got 3150 set up to do a transient. It's going to sag the voltage down to about 42 volts per phase for a duration of 60 seconds. And then it's going to come right back up to nominal voltage. Our PSB is set up to just provide a small output of only 10 amps. It's only 100 watts or about 100 watts just to gain show on the scope, which is the pink line, that the voltage of or the current you can see here, um, like the pink one, 100 watts or about 100, just to again show on the scope, which is the pink line, that the volt of the current is not going to be disturbed, and our output continues operating while we experience this. So now it's going to come over the AFX and hit, we will hit run, and then what we will see on the scope, and you'll probably see the couple of times is a sag in the voltage. The pink line will stay the same, and then we will continue uh, operating. So here we go. You can see. All right, so I saw a quick one there, and we are going to do it one more time. So it's paused. The scope there, you can see clearly that for about 1, 2, 3, 4.5 cycle of or so, we have dropped the voltage down to 10% of the nominal, or about, let's say, 15, and you can see that the pink line shows that the product continues to ride through that event. So if you're in a region where you might experience some voltage sags or dips, so the equipment should be able to ride through the, depending on how long the requirement is. But generally only about 20 seconds is like 20 milliseconds is required, and we are about three times that. If we were to increase this a little bit longer, you would get what's called a PF or power fault on the input. The input immediately, you get a power fault on the unit. It shuts off the output, but then when as soon as the power comes back, it recovers itself automatically, although the output is not enabled at that point. So here you can see. So Let's do this. Okay. Uh, so now it has been increased that time sag time down to about 200 milliseconds, just so we can see what does this happen when the output when you get that power, that powerful error that comes up on the power supply. So now it's going to go ahead and start the AFX again, and then right away there you saw a problem. So we got a PF alarm here on our PSB. Um, so it's going to go ahead and acknowledge that in this case, it actually drove a little bit too much power from our power supply. So we got our voltage exceeded and they didn't get a chance to recover like it would have wanted to. Uh, but normally, the if it's a very short duration but long enough to trip off the output, then the PSB will recover automatically and it's going to go ahead and run this one more time. So that we can see that happens. All right. So we are all set up again and hopefully this time it works. We are going to see a power fault. Uh, we're going to see a power fault on the PSB and then it will come back as soon as the voltage comes back and then we can re-enable the output. So there you saw the output go to zero when the power voltage sag for too long. Our unit no longer has the power fault. That's gone away, but our power out. But our power output is off. We just go back and re-enable the output, and we are good to go. So it is nice that the unit recovers itself automatically as long as that voltage is not gone long enough for the unit to power off completely. So this is what we had the experiment. So I'm just going to show you something else as well here. If we just go and look at this thing right here, this is what we have here. So in this case, let's discuss this a little bit. Um, you see in this uh, graph, let me just make it a little bit zoom out, zoom in, sorry. So if that fits my window, let me see, I'm almost good enough. Okay. So now if you see here, what I have in here is on the x-axis, I have voltage per unit and the time, sorry, on the y-axis voltage, x-axis the time. And as we discussed in our presentation, we have a mandatory operation capability, permissive operation capability that I have defined what those terms are, permissive operation capability here. And if you see, it is starting from 0 to 1.3. This is like per unit calculations. And here we have time. The time is here and it's in seconds, like 1,000 seconds or so. So let's assume for we talk about permissive operations. So it is the operations capability is allowed from point zero 0.01 to point 0.1. This is the time zone, and it is allowed it if it is between 0.50 to point 0.7. Whereas the mandatory, if you look at here, which starts from 0.70 to point 0.9 zero per unit, like this is like the on the upper band, this is on the lower band in terms of voltage, but in terms of time they are up to here, they are almost same, but for the mandatory operation it can go beyond from point 0.1 to somewhere around 1 or so. So in next we say that we may ride through or may trip, that there is a possibility that after this time and up to here it can trip, but this is it like in ordinary cases. But if we have a permissive operation capability, it can go beyond this point, uh, beyond 0.50. Here it's showing like 0.48 or something. So in this next is These are like the different categories we are discussing here. This is like the moment we are talking about category one. So now for the time scale, if you see may ride through or may trip, that this is the time period from here to here. It may ride or trip when the voltage goes from zero point 0.7 to zero point 0.9. In this case, so here we can see range of allowable ratings is shown with these arrows. Default values are here, 2 and 1. These are the so shell trip zones. They are marked with this gray. You can see here. So may ride through or may trip zones are in the white right here, here and here. These areas are shell ride through zones is in the green. So this is here on the top. So it means when we talk about shell ride through is you see during the whole time it's going through, it's riding through, and if it is between zero point 0.9 to 1.1 pu and operating regions describing performance. So this is what we can see in terms of category one. So now moving on to category two, because I didn't address this in the um, presentation. So for the category two, so you see the difference if we go back on here. For example, my permissive operation capacity for category one is here, whereas it looks like it I have more capacity, more capacity for the voltage per unit, and time is there, and probably more time as well. So here at we can see in category two, and whereas the continuous operation capability is here, the green area, it is from 0.90 to 1.10, and here as well in in the capacity in the category number one, it's almost the same. Um, let's see the mandatory operation capability for category 2. See, this is for longer period of time, and the voltage is almost 0.70 to zero point 0.9 here in category 1. We have the same, but it's not for a longer period of time, and we have to discuss um, this rise in voltage between this region to this. And as I said, all these white areas, they're showing the may ride through or may trip zones for category 1. So we are just doing a comparison between category 1, 2, and now category 3. See, you see mandatory operation, it's even for a longer period of time with a higher range of voltage, and momentary cessation is here, whereas the momentary cessation we didn't see here in category 2 or the category 1. So it means when we talk about the momentary cessation, as I said in the video, so it's right here. So we can have this much time and the voltage. For mandatory operations, we have a greater zone here. And in this shell trip zones, they are marked with the gray right here, whereas the light greenish is the shell ride through zones, and operating regions describing performance. So yeah, as I said, default value here, see for category 3, it is here. This is zero point 0.9, whereas in case of category 2, the default was somewhere here close to zero point 0.7, whereas here in this case it was zero point 0.7. Whereas the another default value, that is 2, in category 1, this is somewhere below 0.50, and in case of category 2, it is somewhere at 0.45. That was 0.48 there. So in category 3, this number 2 default value is at 0.50. So we see the default value for the category 3 is more for the 2 points, default value points. So this is like a comparison for the voltage ride through in the three different categories as we discussed. So this is what we have, and as I have already presented the video that you have seen. So thanks. You can give me your comments. Thank you.